Okay, now we're gonna open our second main VI. So I'm gonna show you here. Okay, this is pretty easy to explain. Actually, we only have three numeric controls. That's where the coefficients of the quadratic equation are gonna be, let's say, inserted. Um, so I'm gonna start by editing these numeric controls, and we're gonna see in this indicator the root, right? The root that the equation give us, and in case those roots are complex roots, let's say, I don't know, it has an imaginary part within it, it is gonna shown here in our complex roots indicators, and we're gonna run this program just to see if everything is running okay. As we can see, as we do not have as to say a complex root, we can visualize the roots here in our, let's say, real roots indicator. But what happens if I change these coefficients here? I'm gonna see that it does not apply. I can, let's say, show the roots in my real roots indicator due to because that it has a, let's say, some kind of complex or imaginary part here. So uh, how did I do this? Let's open this sub BI. Okay, I'm gonna start the program, and here's my sub BI. I just used a formula node to encapsulate the formulas that I needed. Here are the numeric controls that I use them as an input for the formula node, and also the outputs to their respective indicators. And here's the part that I told you about. This is the part that calculates imaginary roots, let's say. And what I used was this function called polynomial roots, that it just receives a function px. An option I didn't use it. It just has to do with some other things that I didn't need to use. And on the output, I'm gonna see the roots that it generated, right? And that's that's it. I mean, before using that polynomial function, I used this function build array in order to, let's say, generate an array with these three coefficients in an ascending order, and then pass them through the function to the polynomial function, right? And that's pretty much of the this it's how it works, right? The VI. I can keep changing, and I'm gonna see how the roots change, right? So that's how the program runs. I'm just gonna click on the stop button, and the whole program is gonna stop. And now let's go to the last main VI. Okay, what I did here, I only generated an array of, as the program said, 10 different random numbers. And let's see, let's run the program to see how it works. You can see that here I have an array, the generated array with 10 different random numbers. Then I sorted the array in order to make the subtractions a bit easier. So what I just did was to subtract the first element with the second element, then the second element with the third element, the third with the fourth with the fifth with the sixth with the seventh with the eighth with the ninth, and the ninth with the tenth. So I have 9 different subtractions, and after that I used a absolute value function to not take into account the negative values, right? So after doing these subtractions, I have an array of those results of the subtractions. Let's say 1 minus 14, it gives us minus 13, but as I use the absolute value, I only get the positive value of the subtraction, right? So after that, I search in this array the minimum value and as we can see here in minimum distance indicator, it's the 2, and as you can see, actually it actually is the number 2, and it is located in the index number 8 of the array of subtractions, right? And I'm gonna show you what I'm talking about here. First, I generate the random number array with the for loop, and after that I sort the array. Here's an indicator of the array generated. Then I sort it with this function. It's sort one the array. Basically, it just sorts the array. And after that, with another for loop, I told uh, the I told the for loop that it had to run to ran 9 times. And what it does, it's basically it's receive an index array. So I'm gonna pass the index of the array that I want to use, the value of the index that I want to use, so that it on the output gives me let's say the value that is within that index, right? um, okay, basically that's it. And I did the same with, I used the same function. The thing that happens here is that just incremented the value of the, let's say, the iteration, so that it could give me the next index, the index that I'm in plus 1, right? So that I could make the subtraction as I just explained a few minutes ago. And here's the subtraction, then the absolute value, and after that what I just did was generate another array. Here's what I generated, the array. This is the indicator of the subtractions array, and then I just use the mix and the minimum and maximum value uh, function to search for the minimum distance value, right? And that's it.